Hey everyone, thanks for joining. I know it's late in the day. My name's John Kodamal. I am the CTO and co-founder of LaunchDarkly. Really excited to have a chance to get to speak to all of you today about how we've actually been able to use LaunchDarkly to build and operate our own service, LaunchDarkly, at scale. How we use feature management to advance and evolve our own software stack. So if I could give you a preview of sort of like the two takeaways I'd like you to walk out of this talk with. The first one is that when I think about some of the challenges in software development, I think one of the biggest ones is that the natural state of software is to be in kind of like a state of constant evolution. In a scaling service, there's very little software that you sort of like write and you think it's done. I mean, I've been writing software for 20 years, and it's pretty rare for me to start building a service or write some code, write some function and say, like ship it to production and then say, it's good. It's going to exist like this in perpetuity. I'm going to leave it like this. 5 years later, I'm going to come back and I'm going to find the same code executing, recognizable in the same state that I built it in. Instead, software is kind of constantly changing. You should be expecting that anything and everything will have to change, not because we're bad at writing code, not because what we deploy initially is buggy, but rather because there are changes in externalities that affect the code and cause you to have to evolve it constantly over time. Those changes could be things like changes in scale as you onboard more users onto the service. Changes in input, the way that customers or end users interact with that service might reveal more defects or might require additional changes. And then shifts in business requirements, which is probably one of the most common reasons why we have to change code in a running service. And so when I think about some of the biggest advancements in the way that we build software, some of the things that I've experienced in my 20-plus year career in software development, I think that the changes that we've made in the software development lifecycle, a lot of them have been focused on making the evolution of software manageable. So things like DVCS and CI/CD, they're not just about getting code from local development to production faster. And they're not just about getting you to be to a point where you can ship correct code initially faster, right? They're also about helping you take code and make it manageable to change it over time. So take continuous integration as an example. We write test suites, and when we write test suites, we're not just trying to validate that the initial behavior is correct, we're actually creating a kind of specification, right? So as we evolve that code, the test suite is like an executable specification. It tells us when, as we evolve that code, whether something has changed, which would possibly be a good thing if it's a change that we intended, or potentially be a bad thing if the contract that specification enforces has been broken. And what I want to say, the second sort of like takeaway, besides the idea that software is constantly evolving, the second takeaway is that feature management should be one of those changes in the way that we build software that has that same effect. It's one of those advancements that can change the way and improve the way we evolve software. And I want to demonstrate this with 3 examples of how we've actually evolved the LaunchDarkly service in the face of change by using feature management, by using LaunchDarkly itself. So a little bit about me. Again, I'm John. I'm the CTO. I'm one of the co-founders of LaunchDarkly. I started LaunchDarkly about 8 years ago with my co-founder, who's the CEO, Edith Harbaugh. I guess my career arc has always been, I've worked every job that I've ever worked at has been building developer tools. So that's like over a 20-year career in building developer tools. Prior to LaunchDarkly, I was at Atlassian for 6 years. And I didn't work on Jira, so if you love Jira, I can't take credit for that. If you hate Jira, totally not my fault. And then prior to that, I was at a company called Coverity, and I was building static analysis because I worked on type systems and programming languages back in the day and did some research in that field. So a long career of trying to think about the developer journey and how to give developers an easier time to ship great software, avoid bugs, all of that jazz. And if you're not familiar with LaunchDarkly, I wanted to give a little bit of a background on the company itself. So we were started about 8 years ago. We are the first SaaS feature management platform out there. and we're market leaders in the space. So we started in 2014. We now have over 4,000 companies using LaunchDarkly. We have over 600 employees worldwide, and over 20% of the Fortune 100 are customers of LaunchDarkly. So it's actually the case that many of the experiences that you have using software, either on your phone or through your laptop, there's probably some LaunchDarkly feature flagging going on underneath the hood that you're not necessarily aware of, which is something I'm pretty proud of. And I mentioned earlier that feature management could be a transformational step in software development, something like DVCS or CI/CD, something that you can't really live without. And I think these logos, which are customers that all use the LaunchDarkly platform, are a testament to that idea. You'll notice from this slide that there are some of the traditional software native companies that you can think of. Atlassian itself, actually my former company, is a LaunchDarkly customer, Fubo.tv, AppDirect, and others that you would think of as being native, cloud-native software companies that are at the forefront of modern software development. But those aren't the only customers using LaunchDarkly. We actually have insurance companies using LaunchDarkly. It's actually the case that almost every major vehicle manufacturer, car manufacturer in the world uses LaunchDarkly. An example of that is there's a German car manufacturer that uses LaunchDarkly, and I was talking to one of their tech directors, and they mentioned that their company they have to innovate more over the next 5 years in the space of delivering software and in the way that they deliver software than they have in the previous 50 years in the space of manufacturing vehicles. And that story, that evolution of companies becoming software native, transitioning from software being like sort of an outsourced thing that they did to being a digital first software native company that has software as a core part of their customer experience, that's a really common theme that we hear a lot at LaunchDarkly from our customers. And again, all of that is just testament to the idea that no matter what kind of software you're producing, feature management can be a critical enabler to help you build that software faster, ship it with less risk, and critically evolve it over time, which is something that everybody has to do. So I wanted to spend a minute or two talking about feature management and what it is, in case some of you are not familiar with feature management or really only have a cursory familiarity with what feature management is. For those of you that aren't familiar with feature management and feature flagging, I want to explain the concept really briefly, and I'll do so by making an observation. And the observation is that when most teams ship software, they actually conflate two pretty critical steps of the software development lifecycle. And those two steps are deployment and release. So most companies, so I'll define deployment in a fairly simple way, simplifying the idea somewhat. A deployment is like the act of packaging up an artifact, and that artifact contains all of the change that your engineers have made from the last deployment to the current deployment, packaging it up, putting it on a server, and then pointing a load balancer to it and exposing that change to end users. That's what most people think of when they think of the act of deployment. But that can be different from the act of releasing software. And releasing software should just be the act of exposing that change to end users. If you separate those two steps, you actually gain a lot. But most teams don't do that. So most teams, they'll have a version of the software running in production, say version A, and it'll be exposed to their end users. 100% of traffic is seeing version A. And all of their engineers, maybe you have, say 10 teams working on functionality, and they're iterating, going through code review, et cetera, merging that change to main. And everything that gets deployed when we package up version B, everything that gets deployed is every change that was merged in and integrated since the last deploy, from the last deploy until now. And so when we point our load balancer to that new version B, typically 100% of that traffic is exposed to all of that new change. Now there are some capabilities like canary releases and blue-green deployments that make this a little bit better than that, but many customers that we talk to, many organizations, this is what deployment means to them. And a couple observations about this. First, the blast radius of this is huge. So if something goes wrong and you have to roll it back, you exposed that bad change to 100% of your user base. So the blast radius is uncomfortably large. The second observation is when that rollback happens, you're not just rolling back the faulty change, you're rolling back all of the potentially, hopefully, good change that was shipped out since the last deploy. So if 10 teams are deploying changes and 9 of them built some great software and 1 team had a defect that went undetected in your lower environments, what gets rolled back is not just that defect, but also all of the good positive change that other teams were working on. So it creates this coupling, this uncomfortable coupling between all of your teams that are shipping software. Now let's make a contrast to a post-feature flagging world where we're separating the concept of deployment from release. Deployment is what it was before. It's us packaging up an artifact, putting it behind a load balancer. But what we can do is at the application layer, we can protect our changes with feature flags. So when I have 10 teams shipping change, if each of them can independently feature flag those changes, then I have the ability to selectively turn on that change, each of those independent work streams. And so if something goes wrong, so when I deploy, all of that change, all of those flags are off. And so the deployment process actually has no observable change to our customers. And each team can independently enable a feature flag, probably in a progressive rollout, so a ramped release from 1% to 2% and beyond. And if anything goes wrong, those individual work streams protected by those individual feature flags can be disabled, which means that if one team releases a defect, 9 other teams can progress forward without having to roll back everything. And so if we contrast this to the previous situation, first of all, we have a much reduced blast radius. So I can do a percentage rollout, and I can affect 1% of my customers. And the blast radius can be as small as my detectability, my ability to detect failures. Second of all, this approach has the advantage of decoupling all of those work streams so that not everybody has to roll back. There's a third advantage that I haven't touched on yet, and that's I can do this at a much finer granularity. I can do percentage rollouts at a much finer granularity at the feature level. So I can do them on individual code paths, and I can, because feature flags exist at the application layer, I can do percentage rollouts based on attributes and data and information that's available at the application layer. So in this example, if I'm building some new functionality, this is an example drawn from LaunchDarkly. We built this approvals functionality. So if I build this new approvals functionality, I have the ability to target a small set of early access customers. And I can determine who those early access customers are by leveraging data that exists at the application layer. Another key capability that I gain from this is the ability to measure the impact of that change. So once I have a feature flag and I have a percentage rollout, I can expose that change to both. I have kind of like instantaneously both a control group and an experiment group, a group of people that are exposed to the change and a group of people that aren't. And I can use that for a few things. First, I can use that for traditional experimentation or A/B testing. So I can connect that to, say, a metric that I'm looking to optimize, a KPI, something like engagement or click-through rates, whatever it might be. But also, I can connect this to my observability stack, and I can measure the operational impact of this change, whether that be on something like latency or error rates. I can actually measure the impact winnowed down to the specific set of traffic that is exposed to that change. And this is an incredibly important capability that you can only gain if you're doing these kinds of fine-grained rollouts with feature flags. The last thing that I get is that I get to unlock this for other use cases beyond just that sort of like canary release use case. So I can do things like entitlements. So this new approvals functionality, imagine that I don't intend to release it to everyone. The end state is that I'm only going to release this for premium customers. Well, I can turn this off for early access, and now I can do a percentage rollout targeted just to my premium or enterprise customers. If something goes wrong, again, I can shut that off. But if things go well, I can continue my progressive rollout, releasing it to 10%, and then 50%, and beyond, up to my natural end state where this feature is released to 100% of the targeted audience, which is my enterprise customers. So now that we have a shared understanding of what feature flags and feature management are, I want to talk a little bit about the evolution of LaunchDarkly. And I think the best way to do that is to share a little lore about LaunchDarkly to give you an understanding of like what we went through in some of the earlier days. So 8 years ago, so we're 600 people now. We've got like 4,000 customers. We've got a pretty cool booth over there in the main hall with like 2 stories. It's quite a journey. But 8 years ago, we were a scrappy startup with 2 desks shared by 4 people in a co-working space in downtown Oakland. I'm really going to pay for that one right there. We were building quickly because we were creating a new category. I mentioned earlier that we were the first company building a feature management platform as a SaaS service. That is true. There was nothing out there in the market that did what we were doing. The closest thing was probably things like experimentation and A/B testing frameworks, something like Optimizely or Visual Website Optimizer. But those were very different platforms. They were targeted towards marketing personas and targeted explicitly towards that experimentation use case. We were the first company out there trying to build a platform built for developers with the entirety of the feature management space as our target. And so we were in the state of trying to build this new category, and we needed to prove the thesis that I've shared with you today, that this was an important part of the software development lifecycle, and that we would have companies of any size using us to change the way they build software. We had to prove this to our customers, and we had to prove this to investors. And so early on, we were working really quickly to, like any startup does, to build an MVP and get something out to market as quickly as possible. But we actually got pretty successful. And so from a scale perspective, we kind of became victims of our own success. We had to continuously and quickly evolve our own technology stack to meet customer demand, to onboard customers quickly as they adopted the platform. A second reason why we've had to evolve our technology stack is strategy changes. So in the early days of LaunchDarkly, again, we didn't have as much conviction in the idea that customers would want to consume feature flags from a SaaS vendor. That was something that was pretty hard to get people's heads wrapped around. And so in the early days, we kind of hedged our bets a little bit. We built the stack assuming that people might want to run this themselves. They might want to run this in their own data center on premise, or we might want to be cloud agnostic and provide an offering on Azure in addition to AWS, for example. But what we learned as we hit product market fit and adopted more customers was that those objections weren't real. We could actually go more all in on a cloud native, AWS native strategy. And so we made a shift where initially we kind of refused to use managed services, and we went all in on AWS and started consuming managed services. So we had to quickly evolve our software stack to deal with that change. And then the third reason why we've had to evolve our technology stack is technology evolution. So people still think of us as a startup, but 8 years is a long time in the technology world, and the technology ecosystem has changed pretty massively in 8 years. Just as an example, when we first started out LaunchDarkly, when it was myself and one other engineer, orchestration was still in its infancy. And so like Kubernetes still felt like an academic project. And we were looking at Mesosphere as an alternative to Kubernetes. And we tried Mesosphere. We spent a good month trying to build our stack on top of Mesosphere. And it became pretty apparent that it wasn't really ready for prime time. And so we had to migrate off that. And that's just one example of technology evolving in such a way that we had to move off of that technology and move on to something else. And so if we look at our stack kind of across the board, when we think about aspects of our stack like load balancers, search, job queues, databases, PubSub, message distribution. Across all of these parts of our stack, you can see those themes playing out, where we've actually shifted away from non-managed infrastructure into cloud and vendor-managed infrastructure, where we shifted away from technologies that didn't end up winning, like BeanstalkD, which was the original job queue that we used, which is kind of like bit-rotted now. Nobody really uses that. We've since evolved and started using Amazon's SQS technology. Or places where business requirements have changed, and so that has required us to shift and evolve parts of our technology stack. For example, We used to manage our own pool of HA proxy instances, and we shifted our load balancing over to application load balancers. And actually, historically, ALBs didn't come around until, I think, 2016. So it was a technology that didn't even exist when we started LaunchDarkly, which is pretty wild. And I have to say that as we've evolved our infrastructure, our efforts have actually been tremendously successful. We've gone from a handful of customers using us in the first year or two of the LaunchDarkly service to 4,000 customers using us. We have over 24 million concurrent clients connected to our streaming APIs, and I'll explain what those are and what that means in a moment. We do 20 trillion feature flag evaluations per day, which is more of a vanity metric than anything else because it's not the case that every time you evaluate a feature flag that creates load on our backend infrastructure. That would be a pretty horrible way to architect a feature flag solution. The feature flag evaluation actually happens in SDKs on our customer's own infrastructure. But that does lead to analytics events being sent back to us when you do more feature flag evaluations. And so we have an analytics ingestion pipeline, which is used both for observability into how feature flags are being used. So we can tell you which flags are active, which is incredibly helpful when you want to retire a flag that's no longer in use to eliminate technical debt. It's also used for our experimentation and A/B testing offering, which is incredibly valuable as part of our service. That piece of our infrastructure alone does 16 million requests per second and ingests about 150 terabytes of data on a daily basis, which is kind of pretty impressive scale from my perspective. And it's certainly not something we could support early on. This is something we had to evolve to constantly over time. Here's another view of our architecture in kind of a let me impress you with boxes and arrows kind of diagram. The service itself is hosted in AWS East 1 across 3 availability zones, and we use a number of managed services. In fact, we actually have global distribution. We were multi-region for a subset of these services. And so you might ask, what is all this stuff doing? Isn't feature management simple? Why does it need so much architecture? It actually turns out that feature management is not as easy as you'd expect it to be. And I'll kind of describe our service by breaking it down into, let's call it 3 main components, as well as a 4th service that operates at pretty large scale that I'll talk about as well. So the first piece of our stack is a fairly traditional application monolith. We call it Gonfalon because naming things is hard. It has to do with flagging, and it was written in Go. And I looked that up in the dictionary, and Gonfalon came up. And if you're Italian, please correct my pronunciation. That thing is a very traditional monolith. It serves our REST API, and our front end is actually hosted via the same service. More interesting in our stack is our event ingestion pipeline. As I mentioned, this is the part of the pipeline that does metrics and analytics ingestion. It's the piece of the service that does 16 million RPS and 150 terabytes of data ingest. And this heavily leverages Amazon services, a ton of Kinesis, a ton of DynamoDB, a ton of Elasticache, and other things are part of that stack. A third piece of our service that is quite interesting is what I call our flag delivery network. So I'll explain the purpose of this by kind of walking you through what it looks like when you, as a customer, change a feature flag on the LaunchDarkly dashboard. So if you do that, let's say you just turn a feature flag off, we have to distribute that change in the flag state to all of your infrastructure. And your infrastructure probably consists of a set of servers, maybe some mobile applications, maybe some browsers. We even support exotic things like Roku. So you can do feature flagging on Roku applications. And so we have to get that change out to all of your infrastructure. Now, in a traditional, I mean, the easiest way to think about solving that problem would be something like a polling solution, where your infrastructure reaches out and phones LaunchDarkly and asks, has any feature flag state changed? Maybe you do that every 30 seconds, you get an answer back. What we've learned over time is that for operational use cases, that kind of eventual consistency guarantee where different parts of your infrastructure are polling at different times and get different answers on like a 30-second basis or something like that, that didn't really work well for operational use cases. So we actually use a streaming model, a push-based model. And so the way this actually works is we have SDKs that connect to our streaming APIs, and they establish long-lived, persistent HTTPS connections. We use a protocol called server-sent events, which is a fairly underutilized protocol. Not many people use this at scale. Twitter does for, I think, their DM infrastructure. I learned this recently. And what server-sent events does is it's sort of like a one-way WebSocket. So we don't need bidirectional communications. We just need to push changes to you. And so WebSockets ends up being an unnecessary complexity, and we use server-sent events instead. At any rate, this is the service that supports, at any given time, we have up to about 25, 30, sometimes up to 40 million concurrent connections that are a mix of servers connected to us, as well as mobile devices and browsers connected to us. And the system is set up such that when you change a feature flag on the LaunchDarkly dashboard, we propagate that change to all of those clients. It's actually even more complicated than that because we have two different models. We view servers as trusted clients, and so we can push the entire flag state over to servers. But for mobile devices and browsers, we view those as untrusted clients, so we actually do the flag evaluation at the edge and then push the flag state for that unique individual client over to that mobile device or browser. That way, you can't necessarily look at the business logic behind a feature flag rollout, which is something that we think is unacceptable for clients. And so that fan-out problem ends up being really challenging. So if you're one of our larger customers that, say, has 5 million mobile devices connected to us at a given time, you flip a feature flag on the dashboard, and we're doing the fan-out problem for up to 5 million concurrently connected devices, recomputing each of those devices' flag state and pushing it over the wire. So that's pretty challenging. You didn't think we'd get here when I introduced the idea of feature flags as a service, didn't you? One of my favorite Hacker News comments described us as Booleans as a service. Another one asked, isn't this just a hash table? Another one was like, isn't this like peak VC irresponsibility funding, something like this? I assure you there's real complexity, real computer science going on behind some of the things that we do. So that's our application monolith, event ingestion, and our flag delivery network. The fourth piece of the service that's operating at pretty substantial scale is a giant Elasticsearch cluster. The reason this is interesting is, so when you request a feature flag, you ask for the flag by key. You also provide us context, and the context connects to the rules engine in LaunchDarkly. So imagine you want to do a percentage rollout to 50% of your EAP customers. Then the context is the data in your application layer that says, for this request, is this customer or end user or request part of the early access program? How do I bucket it, et cetera? That's a context. We actually index all of those contexts into an Elasticsearch cluster. We do that for two reasons. The first is observability. So you can ask, for a given customer, what set of flags are they receiving, which variations are they receiving. It's also incredibly useful for usability. We can auto-complete things in the dashboard, especially in the rules engine. So you can determine what attributes are available for targeting. This is incredibly useful for PMs who don't necessarily know what the underlying data model that's being sent to LaunchDarkly is. There are 14 billion documents in our Elasticsearch cluster. And it's an interesting workload because it's super write-heavy and very read-light, which is kind of atypical of a lot of Elasticsearch use cases and workloads. So, when people talk about feature flags, it's easiest to imagine feature flags being used to show or hide new features. And I think a lot of people, that's kind of the limits of what they think feature flags are useful for. In fact, I think the name is kind of a misnomer. Feature flags, features, terrible name. In fact, feature flags should be used in areas that aren't just front-end specific. In fact, the majority of our customers aren't using us exclusively on the front end. They use us for the back end as well. And if I could shift your mindset a little bit, one thing that I would hope you'd take away is that feature flags aren't just a way to show or hide features from end users. It's more about evolving your software to react to change, because change is inevitable, as I mentioned at the start of the talk. And so the customers of ours who are the more advanced users of feature flags think about feature flags as a way of protecting the majority of their changes that they're shipping in production with feature flags. So I want to share 3 stories about how we've had to evolve our software and how we've leveraged feature management to get through that change and evolution safely and efficiently. So the first story is focused on application modernization. And it's a scenario where our business requirements changed. We actually have a strategy to go take our service and go multi-region. And we also have customers that have stronger data localization requirements than we've had before. And that has required us to shift to a new database technology, CockroachDB, that supports those use cases. A second scenario where we've had to evolve is around compliance. We are pretty advanced in terms of some of the compliance initiatives that we support. We have all the basic stuff like SOC 2 and ISO 27001. We recently achieved HIPAA compliance, which means that if you want to send personally identifying health information to us, you can use the platform in that way. And we're at the finish line for FedRAMP compliance. And I've been saying we're at the finish line for FedRAMP compliance for like 4 months now. If you've gone through FedRAMP, you know the pain that I'm talking about. It's an incredibly onerous and time-consuming and expensive process to get FedRAMP compliance. And FedRAMP and HIPAA in particular have led to changes in the way that we've had to build our service, and we've managed that change through feature flags. And then the last change that I want to talk about is cost and performance optimization. So it's a scenario where new technology has come out and we've wanted to capitalize, and we've had to evolve our stack to capitalize on that new technology. So I want to first start by talking about application modernization, how we've evolved our technology stack in flight in a very particular way. And so for us, we were actually migrating our primary data store away from MongoDB to CockroachDB. And obviously, like a migration like that could be incredibly disruptive. We're considered a mission-critical service for our customers, so like the idea of managed downtime is completely out of the question. This is a data store, our MongoDB database, that contains things like authorization, authentication, is really mission-critical. Like the service doesn't run without that data store. And so migrating it had to be an incremental process, and it had to be a process where we had a number of levers at our disposal to roll things back if we needed to. And so feature flags for us ended up being an incredibly critical component of our strategy for doing this migration. It helped us break our migration into smaller milestones. It helped us migrate gradually with precise control. It gave us the ability to reverse changes kind of instantaneously and quickly validate changes as they were going out and measure the impact of those changes. So we actually had 13 separate engineering teams working on migrating various collections from MongoDB over to CRDB, CockroachDB. And that 16 million RPS high-frequency event ingestion service, that was one of the services that we had to migrate over. And again, this was a staged delivery. We couldn't risk everything. Another thing that was really interesting was that each team's footprint in the database and their load characteristics, and therefore the risk that came with that migration was different. So we needed kind of like slightly different strategies for each migration. But we started out with a framework, a shared migration strategy that everybody could use as a baseline and then iterate on to meet their own safety requirements and needs. And so I'll break that down a little bit. So we used feature flags in a very particular way, and we actually had a centralized team define this strategy and provide scaffolding so that every other team could consume the best practices that we defined here. So every feature flag, for each collection, we created a separate feature flag, and each flag had 4 modes. The first one was mode A, and mode A was sort of like the baseline, nothing has changed behavior. We're reading from the old data store. Applications talk to the old data store. There's really literally nothing different in this world. Supplemented to that was the second stage, which we called mode AB. And in this mode, we actually backfilled data from the old database to the new database, making sure that the data was up to date. And then we began writing to the new database. But in this mode, critically, the database A was still the source of truth. We could also couple this with verification flags. So some of the higher risk collections that we migrated, they could actually build separate feature flags that could do verification. And in verification, you actually had a read from the new database. And so you were simultaneously writing to both databases and reading from both databases, but the old database was the source of truth. That was eventually the response that was sent back to our customers. But with a verification flag, we could throw in the idea of checking the answer from database A and database B and ensuring that they were consistent. It turned out that for some collections, this was too expensive. You can imagine that there's a good chunk of overhead involved with writing to 2 different data stores and reading back from data stores and comparing the answers and doing deep comparisons. So we could actually feature flag the verification. We could feature flag the sampling rate of the verification. So we could sample at, say, 1%. So we could verify 1% of responses or 5% of responses, whatever we needed to do. Now, another critical aspect of this is that at any point, we could still roll back, right? We're still writing to database A. And so that means that if something catastrophically wrong happens, we could always go back to the original world where we know things are in a good state. Finally, we kind of hit the point of no return. If we're running for a while, the verification looks good, we're not seeing any anomalies, we're not seeing any consistencies between database A and database B, we can move the flag to mode B, which is where we're exclusively reading and writing to the new database. And this is a point of no return. We can't actually go back here because we're not writing data to the original data store. And that means that if we were to switch back to reading from that old data store, we would have some amount of data loss. And so this was the approach that we used and tailored for every collection. So every team kind of worked off of this same baseline template. We actually created a bunch of scaffolding, including code generation, to make this process easier. We had write-ups set up so that every team could kind of apply this template to migrating their own collection and tailor it to their specific needs. Again, this approach had a ton of great advantages for us. No downtime, gradual rollout that allowed us to monitor the impact and avoid operational errors. And we could roll back, do partial rollbacks. We could do comparisons and verification. And there are cons here, though. We ended up, because of this strategy and the fact that we had 13 teams, all with independent roadmaps doing the migration, we actually had both databases live. In fact, I think our Mongo database is still alive right now. So we have to pay the operational costs of maintaining both databases. We have all of the code coexisting for writing to the old data store and the new data store. And there's also the operational cost of doing the dual reads, dual writes, and verifications involved here. This is actually what the flag looked like in LaunchDarkly. This is a little bit of a hero image from LaunchDarkly, where those 4 modes, A, AB, BA, and B, are encoded in these 4 variations down below. And we could look at a data store by data store basis. So we could migrate the account model. And in this case, the account model is 75% in mode BA and 25% in mode B. So this was an incredibly useful approach to evolving our systems. And this is actually a story that has been repeated by a number of our customers. Many of the advanced users of LaunchDarkly are using LaunchDarkly for this kind of use case. TrueCar is an example of that. TrueCar is a company that has been moving from bare metal on-premise to cloud-hosted on AWS. And we were a critical part of their migration strategy. They had a slightly different architecture. They have like a huge set of affiliate networks, all with different websites, and so they migrated them piece by piece over to AWS. And they actually used LaunchDarkly within Lambda at Edge functions. They integrated LaunchDarkly's Node SDK into their Lambda at Edge functions to essentially build a rules engine within LaunchDarkly and use feature flags to control which customers got migrated over to the cloud-hosted version of those sites versus the on-premise version of those sites. They saw an incredible increase in deployment cadence from deploying once per week to 20x per day by using LaunchDarkly, which is pretty impactful. So I want to move on to a second story around compliance, which is probably one of the not the most exciting topic for a lot of people, but I think compliance is something that we should all be concerned about because compliance is table stakes for a lot of companies out there. 8 years ago when we started LaunchDarkly, the idea of getting things like SOC 2 or ISO 27001 was pretty alien for small startups. Nowadays, through platforms like Vanta and other things, more and more companies at an earlier stage are going through compliance. And compliance can be a real challenge for companies because it can really hinder your speed of development, right? Compliance can create requirements of you that end up slowing down your development teams. And so, I think one of the frustrations that people have with compliance is that it can create custom requirements that aren't universally shared amongst your customer base. And it's hard to maintain that within a single code base. Compliance is also infectious, so it can create scenarios where you can't, say, use third-party services if they don't have the same compliance as you. So maybe you can't use a service if it doesn't have SOC 2, or this is a real problem with FedRAMP, because very few third-party vendors have FedRAMP, and that means that if you're going for FedRAMP, there are a lot of services that you probably rely on that you actually can't use. So how do you get around this? How can feature flags help with this? Well, they can help. We can help you by giving you an ability to customize your software within a single code base through the use of feature flags. So if some customers need to experience your software a certain way for compliance reasons, you can do that and maintain that in a single code base instead of having to deploy different branches or different instances. And it allows you to build better experiences where you can leverage those third-party vendors that you want to use, those best-of-breed third-party vendors that you want to use. But if you can't use those third-party vendors in certain scenarios, you can use flagging to provide alternatives or disable certain pieces of functionality where compliance prohibits you from doing that. FedRAMP is a great example of this. So I mentioned FedRAMP is infectious. If you go through and look at the set of vendors that have FedRAMP moderate, it's a pretty small list. There are a ton of services that we would love to use that we can't use in LaunchDarkly, or we wouldn't be able to use in LaunchDarkly because of FedRAMP. But we've managed to get around that and still maintain a single code base. We actually have a separate instance of LaunchDarkly for federal customers, so it's a separate deploy of LaunchDarkly, but it's the same code base. And we control that divergence in functionality through the use of feature flags. A specific example of this is we use third-party services for messaging and notifications, things like Courier, which is a great platform for managing transactional notifications, and PubNub, which does a lot of our real-time notifications infrastructure. We can't use either of those third-party services in our federal offering. So what we can do is fall back. So if we can't use Courier, we can use something simpler that is FedRAMP certified, like SES, Amazon's offering, to send transactional emails. We can also just turn off functionality. So PubNub is used in a non-mission critical component of the LaunchDarkly architecture. And so we just disable that in federal and say you don't get that functionality. And that allows us to still use best-in-class services and still use the third-party vendors that we want to use and have a great FedRAMP approved offering. So this is an example where we can unship or provide alternative implementations of functionality. And this is great for things like FedRAMP. It's also great actually during incidents. So if like Courier has an outage or if Mailgun has an outage, we can actually feature flag our third-party providers and fall back to an alternative provider using feature flags. So if Mailgun goes down or something, then I can switch to SES as a fallback mailing service. HIPAA is another example of this. It turns out that to support HIPAA compliance, that actually imposed demands on our platform that we didn't want to enforce universally. Specifically, we use a CDN provider called Fastly. We're pretty big fans of Fastly. They've been a partner for us for a long time. And they actually have a HIPAA compliance mode. And what that does for a CDN provider is basically like if you flip the HIPAA bit on specific requests, which is like a specific header, I believe, then it signals to Fastly that they can't cache that data in non-volatile storage. So they have to use memory-based caches. And that's great. So sweet, we can go through HIPAA compliance with our CDN provider. The downside of this is that because you can't use non-volatile storage, it actually impacts cache hit rates negatively, and they actually charge you more for this. So we didn't want to just turn this header on for all of our customers universally, because we'd be paying more to our CDN provider, and there'd actually be a performance hit. So what we did instead is we used a feature flag. And so when we onboard customers that have HIPAA compliance requirements, we sign a BAA, a Business Associates Agreement with them, and we actually add them to a feature flagged segment. And that enables the right bits in Fastly. And so for just that small subset of customers that have HIPAA compliance requirements, we can actually be HIPAA compliant with our CDN provider. And for everybody else, we get all the benefits of higher cache hit rates and lower CDN costs. OK, I'm going to wrap up with a third example around a new technology that has come out and our ability to evolve our technology stack to support that new technology. And the example that I'm going to use is a cost and performance optimization that we got from migrating some of our services over to Graviton from traditional x86 architectures. So this is one of those classic sort of like evolution cases where we're migrating architectures and we want to make sure that the architectural migration doesn't create differences in performance or differences in semantic behavior of those services. And so we did this with a gradual rollout controlled by LaunchDarkly feature flags. And just like the other scenarios, different workloads have different risks. We wanted to stage the rollouts, and we didn't want to jeopardize performance. And feature flags were kind of critical to this as well, because it provided us the ability to measure the impact winnowed down by which architecture we were serving requests on. So we could actually seamlessly route traffic between Graviton and traditional architectures in real time without redeploys. We could target specific systems, non-mission critical systems first, and set up monitoring to actually automatically roll back the shift over to the new architecture should we detect anomalies. And the impact of this was fairly substantial. This was the migration impact that we saw from one specific service, which ended up being like $91,000 a year, which is no small amount of change. It's like half a head count, I guess, depending on whether you're paying Bay Area salaries or what kind of head count you're thinking about. But this was quite impactful for us. This is another look at costs that showed that 20% reduction overall. And again, this is a story that was repeated by some of our customers. For example, Honeycomb actually went through the same migration and utilized LaunchDarkly to do the migration. And they found that even though Graviton was 5% slower for them, it was 20% less per millisecond. So it was a 17% cost savings. And the performance impact was not material to their customers or their specific use cases, which ended up being a win for them overall. So that's my set of stories, 3 sets of stories around app modernization, compliance initiatives, and cost and performance optimizations. And so I'll reiterate my takeaway, which is that feature management isn't just about showing or hiding things from end users. It's actually a way of driving evolution in your software stack safely, and evolution is what we're all doing. I mean, most of the time, we're not just writing brand new code from scratch. We're actually evolving existing code. That's the natural state of software in a scaling system. And feature flags are one of the mission-critical techniques that you can use to do that safely and efficiently and without risk. So that's all I've got. I've got a few minutes. I can take questions if there are any in the crowd. Otherwise, last shout out. One of our customers wrote a book about LaunchDarkly. Michael Gillette wrote a book called Feature Management with LaunchDarkly. We're actually giving away copies of that book at our booth tomorrow at 1 p.m. So if you stop by our booth, we're at 141 at 1 p.m. tomorrow. You can grab a free copy of that book. I wrote the foreword to that book. That's the least interesting part of the book. It's actually an excellent book that Michael wrote. So thank you all. If there are any questions, I'll take them. Otherwise, appreciate it. All right, thanks again.